Hi, this is Marco from Donut Lab. You are watching our battery proof series called I Donut Believe. In this series, we demonstrate the capabilities of Donut Battery, which is the world's first solid-state battery used in production vehicles. This time, we are looking at something we haven't really touched on before. Not the battery itself, but how we make it. In the past, the rule of battery manufacturing has been simple: go big or go home. A conventional battery cell is a hazardous thing to manufacture, so just getting started has required enormous gigafactories, clean rooms, vacuum chambers, billions in capital, and years of waiting before you even see break even. So when we tell people we are ramping to 1 gigawatt hour of annual run rate production this year, the obvious question follows: where is this Donut Lab gigafactory? The honest answer is that you probably wouldn't recognize one if you drove past it. Today we get into why and how our battery technology and our manufacturing approach work together to make scaling look completely different from anything else the industry is used to seeing. Jarkko and Ville will take you through it. So let's go.
Traditional lithium-ion cells have to be built in an inert gas atmosphere with all the humidity removed, across a long list of steps. And the materials in conventional lithium-ion cells are difficult to combine, but ours go together easily and they are not bothered by humidity or the presence of oxygen. That means many of those steps can be dropped completely and many others can get dramatically simpler.
And that means the process can run in a normal industrial environment. That changes the economics of scaling immediately. Lower infrastructure cost, faster factory setup, easier replication, no dependency on specialized facilities. A standard building becomes a production site. An existing warehouse, a logistics facility, or even an old supermarket can be converted. And it changes where the materials come from. Traditional battery supply chains are geographically constrained, concentrated in a small number of countries, increasingly subject to export restrictions and pricing volatility. Our raw material base is fundamentally different. Broader sourcing options, less exposure to single country dependencies, more predictable procurement. Our supply chain is resilient, and we can build one in any continent. All this gives us a very different scaling model.
So with traditional lithium-ion cells, after the stacking and pouching phase, the hard work only begins. Every cell needs to be filled with liquid electrolyte, then cycled carefully with the pouch open for degassing, then stabilized, stored and monitored over a long aging period, then sealed and tested before it is ready. And this can take even weeks.
With our process, when the stacking and pouching is done, we are almost good to go. These stages, typically called formation and aging, can be dramatically faster, hours instead of weeks, potentially minutes in the future, right, Ville?
Yeah, or in some applications, just skip it entirely.
Formation and aging typically consumes huge amount of electricity, equipment, and floor space. These stages alone can present roughly a third of a total equipment capex and up to 60% of footprint. And gigafactory locations are chosen primarily around access to massive renewable electricity. That is how much power the process demands. With our process, we gain major freedom over where we locate manufacturing. Closer to customer, closer to logistics hubs, in existing buildings, smaller units, less capex, flexible locations. That is a major strategic scale advantage.
Conventional lithium-ion is built around standardized cell formats and high-volume production lines and large gigafactory economics.
Our model works differently. I call it postponement and assembly to order. We produce a standardized core product first and postpone the final configuration against the customer's specifications. The early stage, the capex-heavy, process-critical, IP-sensitive part, can be centralized in one larger production unit. That is where we protect the core technology and capture the scale benefits of our most expensive equipment. The later stage happens closer to the customer. Final assembly, pouching, testing, and customer-specific features are done based on the exact use case and delivery need. The 1 gigawatt-hour target Marco talks about for this year may sound almost impossible today. With this manufacturing model, it becomes feasible target. The scaling logic is fundamentally different. This will be very much fun to scale.
And fast and very flexible for the customer. We can offer much more versatility in cell design than any other gigafactory ever could. But that's a story for another video. Back to you, Marco.
Thank you, guys. So, back to the question we started with. Where are Donut's gigafactories? The answer is that we're not even trying to build one. That's not the Donut way. The technology lets us do something very different. Smaller facilities, ordinary buildings, far less energy, and final production close to the customers who need it. And making different types of cells with different characteristics, with flexibility and elasticity never seen before in the industry. That is how we plan to scale to 1 gigawatt-hour this year and way more the year after. Thank you for watching.